Okay, good afternoon, everyone. Okay, so today, right now, we will be starting on acids and bases. All right, so please ensure that you have this set of notes in front of you. Now, this is already the 5th training for Chemistry Olympiad. Now, as mentioned just now, okay, we are moving on to the reactions of acids and bases so that you have a better idea of the basic reactions that acids and bases undergo. For the Sec 4 students, today will be more or less a revision. For the Sec 3 students, you are learning the reactions of acids and bases, which actually some of which you have learned in Sec 2. So hopefully it's also somewhat a revision for you. Importantly, for all of us today, we should revise how to balance chemical equations. That is something that both Sec 3 and Sec 4 Pure Chem students have done. All right. Now, this set of notes is pretty long. I may take about an hour or slightly more than an hour to go through this. Okay. I will try to distill and condense it, but whatever you are not sure of, please do feel free to stop me at any point to ask. Now, these are the learning outcomes that are taken from the O-level Pure Chem syllabus. We will go through them one by one today. Okay. So let's go quickly on to page 2. So very often, students will ask, why must we learn about acids and bases? The answer is because acids and bases are two important categories of chemical substances around us. Many of the substances around us are acidic or basic. So examples of acids in our life, citric acid, okay, which is found in citrus fruits like oranges, lemons, lime. Ascorbic acid, which is also known commonly as vitamin C. So these are examples of acids in our daily lives. All right. Another important one, which bio students should be interested in, is carbonic acid. All right. So this is the formula of carbonic acid. Now, what's interesting about carbonic acid is that when dissolved in our blood, okay, blood is mostly water. All right, so carbonic acid is commonly found in our blood. Where do you think it really comes from? Well, it actually came from this. Okay, it actually came from here. Now, carbonic acid dissociates and ionizes in aqueous solution to form H+ ions. Okay, which really goes to show that it is an acid because it's able to produce H+ ions when it dissociates and ionizes in water. All right. But something else that's interesting is what else does it produce? Now, it produces what we call the HCO3- ion, otherwise known as hydrogen carbonate or bicarbonate ion. So this is one of the ions that is in the Pure Chem syllabus, HCO3-, the bicarbonate ion. But many students tend to overlook this. All right. So please, let's take this down. Now, this is very important. Okay, this reaction that I've just written out is what maintains the pH of blood at a constant level. Okay, so for those of you doing pure bio, you will be familiar with the fact that your blood, or rather your entire body's pH, temperature, all these conditions must be kept constant. In particular for blood. Now, blood, it happens to be the place where many chemical reactions take place, right? And in blood, there are many enzymes which help to speed up these chemical reactions taking place in your body. So it is very important for the pH of blood to be kept constant because the enzymes present in your blood can only tolerate a very narrow range of pH values. The enzymes will not work if it's too acidic. The enzymes also will not work if it's too alkaline. So it must be at an optimum pH level. And the way your body does this is to use this particular reaction with carbonic acid to regulate the pH of your body. All right? Ken? Now, how about in the lab? We also have a lot of acids in the lab. So you are familiar with this because in lower sec, you went to the lab to do a few experiments, simple experiments with acids. The most common acids in the lab are the first three: HCl, HNO3, H2SO4. hydrochloric acid, nitric acid, sulfuric acid. All right, so the first three are found in the lab. This is what you will use mainly for your experiments. However, please also realize that there are more acids found in the lab, such as ethanoic acid, which has this formula CH3COOH. We also have phosphoric acid, which is H3PO4. All right, so these are the 5 acids that you can find in the school laboratory. Now, some common properties of acids that you've studied in lower sec. Acids have a sour taste. Acids will turn blue litmus paper red. Acids dissolve in water to form solutions, which can conduct electricity. Finally, in lower sec 2, you probably learned the reactions of acids. Acid plus metal, acid plus base, acid plus carbonate. So if you look at the formula, now you have learned chemical formula. If you look at the formula of the acids, they all have one similarity, which is the acids all contain hydrogen in their formula. Okay, regardless of what the acid is, if you look at the chemical formula, there is H inside it. They all contain hydrogen in their formula. All right, and this leads us to the definition of what an acid is. All right, so if we move on to page 3, right at the top of page 3 of your notes, is the definition of acids. An acid is a substance, it's a chemical substance that dissociates and ionizes to give H plus ions in an aqueous solution. So this is quite an important definition. First, what is the meaning of dissociate? Dissociate means separate. For example, we have HCl. At first, HCl is together. The H and the Cl is bonded together by a covalent bond, right? Hydrogen is a non-metal. Chlorine is also non-metal. So it's a covalent bond between hydrogen and chlorine. They are both non-metals, so they share valence electrons to form a covalent bond. However, the moment it's dissolved in water, it separates. What it means is that the covalent bond breaks. The H and the Cl is now separated because the covalent bond has broken. All right. So for the Sec 4 students, I hope you remember this is a covalent bond. And if you are breaking a bond, bond breaking takes in energy. And this is why you can see that the first step, which is dissociation, is bond breaking. Dissociation is endothermic. But it's not just about dissociation. It's also about ionization. Ionization means form ions. So for the Sec 3 students, you have learned ions, right? You have learned Na+, Cl-. Ions are formed when atoms lose or gain valence electrons. Ions have charge because when you lose electrons, you gain electrons, you become charged. So in this case, the charge is H+ and Cl-. Okay? Finally, importantly, this takes place in aqueous solution, means it's dissolved in water. Okay? So I repeat, there are two things that happens. One is dissociate, which is to separate. The second thing is ionize. Now, so my pure chem students in Sec 4 might wonder, oh, so it involves bond breaking, so it takes in energy from the surroundings. But does it only take in energy? When HCl dissociates and ionizes, does it only take in energy? The answer is no. Dissociation takes in energy from the surroundings. However, ionization releases energy when the ions interact with water. Remember, it's dissolved in water. So the charged ions form interactions with water. The H+, the Cl- charged ions can form bonds with water. Therefore, ionization in this case and the dissolving of the ions releases energy. So on the whole, the overall reaction releases more energy than it takes in. And that's why dissolving an acid in water is actually exothermic. It releases more energy than it takes in. All right, for my Sec 4 students. Okay, so this is the definition of an acid. So points to take note of as is listed there. An acid must be dissolved in water. That's why the state symbol is aqueous. Aqueous means dissolved in water. Next, an acid must give H+ ions when dissolved. Not everything with hydrogen in its formula will give H+. I've given you some examples there. Ammonia, NH3 is not acidic because NH3 doesn't produce H+. NaOH, not acidic. It doesn't produce H+. Okay? So now time to think. HCl, I just gave you example of HCl in the aqueous solution. But HCl can also be a gas, right? It's just a simple molecular structure that exists as a gas. So is hydrogen chloride gas and acid? If it's hydrogen chloride gas, is it acidic? The answer is no, because it needs to be dissolved in water in order to produce or in order to dissociate and ionize to produce H+ ions. So in the gaseous state, there are no H+ ions. Therefore, HCl as a gas will not be considered an acid. HCl as a gas will not behave like an acid because it doesn't have H+ ions. Okay? Okay, so this is an important concept. For the O levels, this is commonly tested, not just for chemistry Olympiad, but for the O levels, you need to know the state matters. If it's not dissolved in water, it is unable to produce H+ ions. If there's unable to produce H+ ions, it will not behave like a typical acid. Okay, so this is an important concept to get. So hopefully this is a revision for some of you here. You realize this. Now, not only a gas, if it's a solid, it won't behave like an acid as well. If it's a liquid, it still doesn't behave like an acid because liquid means it's pure. It's not dissolved in water. The only state where it behaves like an acid is when it's dissolved in water, aqueous. Okay? So moving on. So now that we know the definition of an acid, how else can we elaborate and describe what acids do or what acids are like? So there are two important terms to describe acids, what they are like. The first thing is called what we call the basicity of the acids. All right. The best way to understand this is to look at the equations that show you the dissociation of acids. So just now, Mr. So has written down this one, right? The HCl becomes H+, Cl-. This is the equation that shows you the dissociation of HCl when dissolved in water. So now we can continue to write the dissociation equations for other acids. First, we have HNO3. HNO3 is called nitric acid. So nitric acid, HNO3, can dissociate to form H+, NO3-. All right. So it forms 1 H plus, 1 NO3 minus. Next, we have H2SO4. Now, H2SO4's name is sulfuric acid. So sulfuric acid dissociates and ionizes in aqueous solution. But now you realize it's 2H plus. Why 2H plus? So let's revise. To balance an equation, the idea is the number of atoms must remain the same on the left and right side of the equation, right? That's the basis for balancing a chemical equation. We must ensure that no atoms are destroyed or created. So if I have 2 hydrogens on the left, I must also have 2 hydrogens on the right. So then, do we write H2 plus or do we write 2H plus? What's the difference? Okay, I hope my students remember this. 2H plus versus, let's say, H2 plus. There is a difference depending on whether you write the 2 outside or below. Now, when you write 2H plus, what you mean is this. 1H plus, 2H plus. They are not bonded. The 2H plus ions are not bonded. What you mean to say is it produces twice the amount of H plus. The 2 in front means twice the amount of H plus. The 2 H pluses are not bonded together. However, if you write the 2 below, what you're saying is this, The 2 H's are bonded. So when you write the 2 below, what you are trying to say is 2H bonded together. That's what you actually mean. So whether the 2 is outside or below makes a difference because the meaning is different. Okay, so for the Sec 3s, I hope you take this down. This will be very helpful when you study balancing equations, which is what you're currently doing in class. For my Sec 4 students, I also hope you take this down. I hope you remember this from what I taught you last year. Okay? So when we write the 2 outside, what we mean is twice the amount. So we write the 2 outside when balancing equations. You will put the 2 or the numeral, the coefficients outside. This we do during the balancing of equations. Okay? So after we have taken this down and understood this, can you please give me a thumbs up so that I know that you are done with this and I can move on? Okay, thank you. Okay, so now we write 2H plus because it still produces H plus. Acids produce H plus, just that sulfuric acid produces twice the amount of H plus. And because it produces twice the amount of H plus, it is known as a dibasic acid. All right, because it produces twice the amount of H plus. Dibasic means 2 H plus ions are formed per molecule of acid dissociated. So one H2SO4 molecule produces 2 H plus. That's the meaning of dibasic. Okay, and needless to say, the last one, H3PO4 phosphoric acid, is tribasic because it produces 3 H plus ions per molecule of acid dissociated. All right. Now, at this juncture, I would also like to cover something else which is related. Now, do you realize all of them are acids because they produce H+? Okay, this is the definition, produce H+ when dissolved in water. But what other ion is produced is also worth investigating. So for the Sec 3s, you have just studied all these ions actually, right? So you can look at the first one, and let me zoom in. Nitric acid produces H+ and NO3-. Now, NO3- ion has a name. The name is nitrate. Right? So if I want to form nitrates, make nitrate, I must start from nitric acid. If I start with nitric acid, I end up with nitrate. Next, Cl-, chloride. And that's why if I want to make chlorides, I start from hydrochloric acid. Finally, SO4 2-, sulfate. So if I wanted to make a sulfate, I have to start from sulfuric acid. Now this now explains why in Sec 2, your science teachers probably taught you to memorize, right? They taught you to memorize that, oh, nitric acid will form a nitrate. The salt's name will end with a nitrate. Sulfuric acid, the salt's name will end with sulfate. Now you understand why. Because these acids dissociate to form H+ and the anion. The anion depends on which acid you had started with. Okay? Now, the next thing that my Sec 4 students probably should listen up on now is, how does basicity matter? Why is it so important to know whether something is mono, di, or tribasic? If you read the definition, dibasic means 2 H+ are formed per molecule of acid, which means that a dibasic acid has more H+ ions. So for example, if I had 1 mole per dm cube HCl versus 1 mole per dm cube H2SO4, do they really have the same amount of H+? Do they really have the same concentration of H+? The answer, of course, is no, right? Sulfuric acid, even though it's 1 mole per dm cube, the concentration of H+ is actually 2 moles per dm cube, because sulfuric acid dissociates to form 2 H+. So if I start with 1 mole per dm cube sulfuric acid, I actually have 2 moles per dm cube H+. So we say that dibasic acids have a higher concentration of H+ compared to monobasic acids of the same concentration. Sulfuric acid will have a higher concentration of H+ than hydrochloric acid. Okay? So how is that important? It means that reactions involving sulfuric acid will be faster. The speed of reaction is faster if you use sulfuric acid compared to hydrochloric acid. Because sulfuric acid is dibasic, it produces 2 H+ per molecule. Therefore, the concentration of H+ is higher. Okay, so the basicity of acids has an impact on the speed of a chemical reaction involving the acid. Okay, so I hope my Sec 4 students, okay? If you're okay with that, can you please give me a thumbs up? I'm saying this because perhaps you'll see it later on in your workbook, your TYS. They always love to make you all compare between HCl and sulfuric acid. So hopefully you realize that sulfuric acid is dibasic, produces a higher concentration of H+ ions than hydrochloric acid. Okay, moving on to the next important concept, which is strength of acids. Now, strength means strong versus weak. So what does it mean by strong acid? What is a strong acid? A strong acid is a substance that dissociates and ionizes completely when dissolved in water, and this gives a high concentration of H+. So for example, nitric acid is a strong acid because it dissociates completely. 100% of the HNO3 will dissociate. At the end of the reaction, there's no HNO3. It's only H plus and NO3 minus. Okay, it's complete. However, weak acids, they dissociate and ionize partially and reversibly when dissolved in water to give a low concentration of H plus ions. So you can see this in the example, CH3COOH. You notice an arrow is double direction, forward, backward. This means that it's reversible. It can dissociate to form H plus, but the H plus can also combine back to give back the covalent molecule. So weak acids like ethanoic acid, so this is ethanoic acid, they dissociate partially and reversibly. As a result of that, the concentration of H plus from ethanoic acid is lower. Okay? So this is the idea of strong versus weak acids, the acid strength. So now let's move on to the main meat of today, which is page 5. How do you mathematically express the strength of an acid? You can make use of this term called the acid dissociation constant. The short form for this is Ka. Okay? So let's say if I have an acid with a formula HA. Now, A can be anything, okay? Any group can be Cl, can be NO3, can be sulfate, whatever. So let's say we use HA as a general term. HA dissociates to form H plus and A minus. It must have H plus because it's an acid, right? So the Ka, the acid dissociation constant, can be expressed as the concentration of H plus. So in chemistry, when we write square brackets, it means concentration. So bracket H plus means concentration of H plus. Bracket A minus means concentration of A minus. Finally, bracket HA is the concentration of undissociated HA. All right, so you can see that the Ka is defined as the concentration of H plus times concentration of A minus over concentration of undissociated HA. Okay, so you are not expected to do calculations, but you need to know how to relate this to acid strength. A higher Ka means it's a stronger acid. Why? If you look at the formula for Ka, the H plus is on top, numerator. So if the Ka is bigger, it's because the numerator is bigger. It means you have more H plus. More H plus means stronger acid, because there's greater extent of dissociation to form a higher concentration of H plus. Conversely, lower Ka means weaker acid. So what you need to do now is to now relate Ka to the strength of acid and see the trends. So now we're going to go through a few trends. The first trend is group 7 or group 17. All right, so for my Sec 4 students, it's group 7. For the Sec 3 students, this is group 17. All right, so group 17 contains fluorine, chlorine, bromine, iodine. These all form acids. HF, HCl, HBr, HI, all of them have H because they must produce H plus. If you look at the Ka values, you can clearly see as you go down group 17, the Ka increases. It goes from 10 to the power of -4 to 10 to the power of 6, 10 to the power of 9. So you can see that Ka increases, meaning the acid becomes stronger down group 17. Now let's relate it to the covalent bond strength. The bond energy is the amount of energy that needs to be taken in to break the covalent bond. You can clearly see the covalent bond takes less and less energy to break. The covalent bond becomes weaker down group 17. So now you clearly see the trend. The acid is stronger when the covalent bond is weaker. These are linked, and this makes sense because we said that for an acid to be strong, it must dissociate completely. To dissociate means to break the bond. So if the bond is weaker, it requires less energy to be broken. As a result, the extent of dissociation is greater and the acid is stronger. Okay? For my Sec 4 students, I hope you recognize these tables and this question. I'm not sure if you remember where this came from. Let's ask. Let's see whether people remember. Audric, do you remember where this came from? Do you recognize this question?
Is it in the TYS?
No, it's not in the TYS. Okay, never mind. Let's spare you first. Let's ask someone else. Junwei, do you remember where this came from?
The notes.
The notes. Okay, my notes are. No, also not correct. Jin Kang, do you remember where this came from or not? Have you seen such a question before?
Is it like the end of year?
Yes. This is the end of year exam for Sec 3 last year, right? I said this question, right? Describe how the acid strength changes down group 7. Then you relate it to the covalent bond strength. So this was the question, right? It was a 5-mark question, I recall. All right, so this is one of those database questions that could potentially come out, okay? Now, this is for group 7 or group 17. Now let's move to some different trends. If now we look at the organic acids are acids that contain carbon, okay? They have carbon atoms inside the acid. So these are all acidic, okay? All of them are acids. Let's just focus on the Ka values. If you look at the values closely, what can you say about the values? The Ka becomes smaller or bigger? You must look at it carefully, because these Ka values have negative powers, right? So if we were to look at the values closely, what would you say about the Ka values? Perhaps can we have Kanishka? What can you say about the Ka values? They become bigger or smaller?
Smaller.
Smaller. So negative powers must be careful. It goes from -4 to -5. If the Ka becomes smaller, that means the acid becomes weaker. All right. So you can see that as the number of carbon atoms increases, the acid actually becomes weaker. All right. Now, the reason why, the exact reason why, you don't need to know, but what's important now is to see the trends. Okay. Now let's move on to the next one. We are now on page 7. Now let's compare the strength of organic acids with different atoms attached to them. So now the carbon atom is the same. Got 2 carbon atoms for all of them. But let's look at what atoms are attached. So when you have H versus when you have Cl versus when you have F, right? So when you have H, Cl, F, how does the Ka change? So firstly, you need to know, we studied chlorine and fluorine, right? In particular, we have said something about their electronegativity. All right. So what can you say about fluorine, F, in terms of electronegativity compared to the other atoms? Okay, Junwei, do you remember fluorine electronegativity compared to the rest? What can you say about fluorine?
Fluorine has a higher electronegativity.
Yeah, higher electronegativity, right? In fact, this is the most electronegative. Okay, fluorine, most electronegative. Okay, so from H to Cl to F, the electronegativity of the side atoms, okay, we call it the side atoms, increases. H, Cl, F, right? So what happens when the electronegativity increases? What do you see about Ka though? Okay, let's ask Sydney. What do you notice about Ka as you go from H to Cl to F? Does it become bigger or smaller?
Bigger.
Bigger. So Sydney, that means the acid becomes
Stronger.
yay. So do you realize by substituting H for Cl or H for F, the acid becomes stronger? Okay, and that's the trend. So again, you don't have to know the reason why. Okay, you can study more the reason why later on when you do more chemistry, but this is a trend. Okay. So what do you think is the Ka value of the acid below that? So this one very commonly tested in your O-level pure chem as well. They will always give you some data, and after ask you to predict something, right? So you need to predict now what the Ka will look like, what the value will look like. The way to do this is to really focus in on the side atoms because clearly it's related to the previous part. It's all about the side atoms. So right now, you have 3 fluorines attached. Not just 1, not just 2, but 3. As Jun Mei said just now, fluorine is highly electronegative. So now you have 3 of it. Based on the trend that you have deduced, what do you think the Ka will be like? Do you think the Ka will be bigger or smaller? Ethan, do you think the Ka will be bigger or smaller?
Bigger.
Bigger, right? Because you have more fluorine atoms attached. So the Ka becomes larger than 2.19 times 10 to the power of -3. It's larger than just having 1 fluorine. Okay? And that's because you have 3 electronegative fluorine atoms attached. Okay, the more electronegative atoms attached to your acid, the larger the Ka. Okay, so of course, this means that the acid is stronger. Okay, so the acid at the bottom has a name. You can want to copy down the name so that you can Google later. Now, this is called trifluoroethanoic acid. Okay, I hope you realize what trifluoro means. Tri means 3, fluoro means F. So this is ethanoic acid with 3 fluorine atoms attached. Trifluoroethanoic acid. This is a common acid used in the chemistry lab as well as the biology lab. Now, this one has a different name also. Okay, organic chemistry is more complicated because it was discovered a long time ago. So organic chemistry has many names for the same thing. So trifluoroethanoic acid is also known as trifluoroacetic acid. Okay, so for my Sec 4 students, we are going to do organic chemistry soon. Whenever you see F, ace means the same thing. Ethanoic acid, acetic acid, they are the same thing. Equals. Okay, it's the same thing. All right. Now, the actual Ka value I will also give you. The actual Ka value for this acid is actually 5.89 times 10 to the power of -1, you know. So it's definitely much bigger. All right. Definitely much bigger than 2.19 times 10 to the power of -3. Okay. Now, where did I get this Ka value from? From the internet. Okay, I just searched for it. Having said that, how do you actually find the Ka value? You will need to do experiments, measure its pH. Then after, you can do some calculations to find out the Ka value, which is what you will do in A-level. Okay? Now, I've spent a fair bit of time talking about Ka and how it's related to acid strength. Hopefully, you know now, if Ka is larger, the acid is stronger. And I hope you can see this ties in very well with database skills. If I were to give you the trends and data, can you actually infer the trends? Can you actually use these trends to do some predictions? I hope the answer is yes, because these are the skills that you need as a pure chemistry student. Okay? So if I may move on now to the reactions, please give me a thumbs up if you're okay and you understood what has been covered so far. Okay? Okay, I think the majority are okay with this. Now, the next part is all about the reactions already and about the balancing of chemical equations. I will go fairly quickly, but at the same time, like I said, I hope we have the knowledge that we are here to learn how to balance equations properly, okay? Okay, let's move on to the reactions of acids. Now, there are 3 reactions of acids. The first one is acid plus metal gives salt and hydrogen. Please remember, metals always give hydrogen. Okay, this will be important later on when you learn metals, the topic of metals as well. Okay, acid plus metal gives salt and hydrogen. However, you need to know there are certain metals that do not react with acids. Copper, silver, gold, they are unreactive with acids. So if I put gold into hydrochloric acid, nothing happens. If I put silver into nitric acid, nothing happens. All right. Next, there are certain metals that are too reactive. Group 1, potassium, sodium, very reactive. So cannot add it to acid because they are explosive with acids. All right. So let's recall how to test for hydrogen. Hydrogen, we place a lighted spleen, right? At the mouth of the test tube. And if hydrogen gas is present, the lighted spleen will extinguish with a pop sound. Okay, so this is what you have covered in lower sec science as well as in sec 3. But today our main job is to learn how to balance a chemical equation. We will skip example 1. Let's just go straight to example 2. Calcium plus hydrochloric acid gives you calcium chloride and hydrogen. It is important that you realize it's calcium chloride. How do I get calcium chloride? First, the salt's name starts with the metal. The metal is calcium, so it's calcium. The second part of the salt's name comes from the acid. Remember just now we said chloride comes from hydrochloric acid. Okay, so hydrochloric acid produces chlorides. That's why I know it's calcium chloride. Now, to balance the chemical equation, the first step is to write out the chemical formula correctly. What do I mean by this? Calcium chloride is not CaCl. It's not CaCl. You need to think through first. Okay, calcium chloride is an ionic compound. What is the formula of calcium chloride? Ionic compound got charge. I need to think. Calcium, group 2, 2 plus. Chlorine, group 7 or group 17, minus. So immediately the problem comes, right? It's Ca2 plus for calcium ion, chloride ion is Cl minus. So clearly, right, the plus and minus are not cancelling out. There's 2 plus, there's 1 minus. Therefore, you need 2 chloride ions to balance out 1 calcium. So it's CaCl2 as a result. This is the crucial first step. Many students are very, very impatient. They just straight away go on and write CaCl. That's not correct. Think through the charges first, the positive and negative. Make sure they cancel each other out. Next, hydrogen. Now, whenever you have hydrogen, anything ending in gen must be diatomic. So oxygen, O2. Hydrogen, H2 in this case. So it's important to know that it's hydrogen gas, so it's H2. Hydrogen as an element is diatomic. Oxygen as an element is also diatomic. So once you have written the chemical formula out correctly like this, 50% of the battle is won. The next 50% is just to count the number of atoms on both sides. So for example, okay, over here, the teacher has counted for you, right? On the left side, you have 1 calcium. On the right side, you have 1 calcium. But the problem comes when you look at chlorine, for example. 1 chlorine on the left, 2 chlorines on the right. You know this cannot be correct because you cannot create or destroy atoms. You must have the same number of atoms on the left and right. Therefore, to balance the equation, you must add coefficients next to or in front of. Okay, I hope you know it's in front of. So we will add a 2 in front of HCl so that you have 2 chlorine atoms. You will never ever add numbers below because the chemical formula is fixed. HCl is HCl. You cannot have HCl2. Cannot. So the 2 goes in front. That's balancing. All right. Remember, we said the 2 in front means 2 times the amount of HCl. Okay? Again, so with that, the balance equation is Ca plus 2 HCl forms CaCl2 and H2. Now, in addition, after balancing symbols if necessary, if the question requires you to add state symbols in, you add. If the question didn't say, don't add. Now, you need to know state symbols. There are 4 state symbols. There's solid, liquid, How would you know if something is aqueous or not? You need to know firstly, acids and alkalis are aqueous. Hydrochloric acid, HCl bracket AQ. Sodium hydroxide is an alkali, so sodium hydroxide bracket AQ. Now, besides acids and alkalis, most salts are dissolved in water because they are soluble in water. However, there are some salts which are insoluble. Okay, so you will learn more about them in a different chapter. Can? So these are the ones that you need to know which are aqueous. So now there's a lot of quick check questions. We're just going to do the first one from quick check 2, which is zinc plus nitric acid blank plus hydrogen. So now we think, okay, so this is clearly the salt. What is the salt formed? The salt form must start with zinc. Remember, the salt's name always starts with the metal. In this case, zinc. The second part of the salt's name comes from the acid. The acid is nitric acid. Nitric acid produces nitrate. So the salt's name is zinc nitrate. This is a crucial first step that you must do mentally before you start writing. All right. Now the next step is, of course, to write the correct formula. Please don't rush. You need to know that zinc is Zn. Nitric acid is HNO3. Zinc nitric acid. The next step is zinc nitrate. Zinc nitrate is the complicated one because it's an ionic compound. You need to think of the charges. All right. Okay, so for the Sec 3 students, let's see. Okay, we have just gone through this in class, right? So zinc has a charge of something. So let's see whether we remember the charges. Kyler, do you remember what charge does zinc ion have? You can type in the chat. Oh, sorry. Yes. Yeah, Kyler, you can type in the chat or you can just unmute. You unmute yourself, right? So just unmute yourself and
I
answer.
think it's 2.
2 what?
2.
2 plus. Very good. So zinc is Zn2 plus, is fixed. And you have to memorize this. All right. So for my Sec 4s, I hope we have memorized this Zn2 plus. Nitrate is NO3 minus 1. So now you immediately realize the problem, right? Again, the problem is, okay, the plus and minus do not cancel out. In order for the plus and minus to cancel out to give no overall charge, I will need to have 2 times the nitrate ion bonded to zinc, bonded to. So I have 2 nitrates bonded to zinc. Bonded to means the 2 goes below. So I put a bracket around the NO3 and put a 2 below because it's bonded to zinc. Okay? So this is the formula of zinc nitrate. Now, why do we use brackets? We use brackets because the nitrate ion is polyatomic. There's more than one ion. It's NO3. All right? Hydrogen is next. Hydrogen is not H. Hydrogen as an element is H2. It's diatomic. All right? Now, one good strategy in balancing this type of equations involving nitrate sulfate is, can you treat the nitrate as a unit? The nitrate is one block. NO3 is one block. NO3 is one block. So now immediately it's clear, right? On the left-hand side, you got 1 nitrate only. On the right-hand side, you have 2 nitrates. It's not balanced. It's not the same number of nitrates. Therefore, to balance it, what should I do? I need to add a number somewhere to balance it. Okay, so Alicia, can you tell me where will I balance it? Where will I add a number to balance this equation? Can you type in the chat, okay, Alicia? Where will I add a number to balance the equation? Okay, if not, maybe we can get Junhon. Junhon, can you also add, where will we add a number to balance this equation? You can type in the chat or you can just unmute yourself. Okay, so you can see that this equation, there's only one nitrate on the left and two nitrates on the right. So you treat the nitrate as one block. So you're right. Okay, so in terms of balancing the equations, you will need to add a number in front of where you need more nitrates. You need two nitrates on the left, therefore it's 2HNO3. Okay. Now, so let's now add in state symbols. Zinc is a metal. Metals are solids. Nitric acid is an acid, so it's aqueous. The salt is aqueous. And finally, hydrogen is a gas. All right, so solid, aqueous, aqueous, gas. So this is quick check too. Okay, I hope the rest of you will treat this as a revision. I hope the rest of you will complete B and C as well yourself. All right, so later on, I'll just quickly write the answers and I'll write in the group when we have finished. Okay. So this is quick check 2. Now let's move on to the last 2 reactions. I think today I will finish the acid reactions. The next training session, we will continue with bases. All right. So let's go through the next reaction, which is acid plus base. Okay, acid plus base forms salt and water. All right. Now, acid plus base forms salt and water. This is a neutralization reaction. It's neutralization because it forms salt and water, which are neutral in pH, okay, neutral products. So what is a base? Important to note, bases are metal oxides or metal hydroxides. So you read oxide, hydroxide of a metal, then you know it's a base. So for example, zinc oxide is a base. In this case, sodium hydroxide, base. All right. So let's just go straight to example number 1. You can see that there's a 2 in front of the HCl because zinc chloride is ZnCl2. All right. Now let's go through the next one, which is sodium hydroxide plus nitric acid. This forms sodium nitrate. Start from the metal is sodium. The acid determines the anion, right? So it forms the salt, sodium nitrate plus water. So again, the chemical equation must be careful. Sodium hydroxide is NaOH. Nitric acid, HNO3. Then you must be careful here. Sodium is Na plus, cause group 1, so it's Na plus. Nitrate, NO3 minus. Oh, for once, the plus and minus are cancelling out perfectly. Therefore, it's NaNO3 plus H2O. Now, this equation is perfectly balanced, which is great. All right. Now, the next one is ammonia, aqueous ammonia. So many of my students always forget this. Now, aqueous ammonia forms ammonium chloride. Ammonia becomes ammonium. Now, it forms ammonium chloride. And of course, it forms water. However, you will realize the equation is just written like this. Whenever you have aqueous ammonia, the equation is just written like this. You don't actually see H2O on the right-hand side. Why? The reason is because the H2O formed is then used to dissociate the ammonia. All right. So NH3 needs to have H2O in order to react like a base. So the H2O form is immediately used up to dissociate the ammonia. That's why you will not have a H2O on the right. Okay? Ken? So with that, we finished examples 1, 2, and 3. So again, please check through and try out quick check 3 yourself so that you can prove that you can balance the equations. Finally, we move to the last reaction for today, which is acids plus carbonates form salt plus water plus carbon dioxide gas. So again, it's the same principle. in terms of naming of the salt, the first part is the metal's name. So in example 1 is magnesium carbonate. So the metal is magnesium. So the salt's name must start with magnesium. Then the second part is from the acid. Hydrochloric acid, chloride. Okay, so this is acid plus carbonate. So it produces salt plus water plus carbon dioxide. To test for carbon dioxide, we bubble the gas into lime water. Okay, and a white precipitate is formed in lime water if carbon dioxide is present. So just now, hydrogen was lighted splint, extinguishes with a pop sound. Now carbon dioxide, a white precipitate, is formed in lime water. So let's go through one more example, example 2 and example 3, and we'll call it a day, right? Now first we have calcium carbonate, calcium, Ca2+, cause group 2. Carbonate, CO3 2-. So just nice, 2+, 2-, the positive and negative cancel each other out, so it's balanced. So the formula is just CaCO3. Plus hydrochloric acid is HCl. Now it forms calcium chloride. Again, must be careful. Calcium 2+. Chloride group 7 or group 17. It's only 1-. So again, there's a problem. 2+, 1-. is not the same magnitude of charge. Therefore, you must ensure that you have 2 chlorides bonded to calcium. So CaCl2 is the formula of calcium chloride. If you don't write CaCl2 correctly, nothing else you do will make a difference. So it's important to write CaCl2 correctly. Plus H2O plus CO2. Then immediately you realize, oh, the chlorines are not balanced. Therefore, I need to add a 2 in front of the HCl. I need to have twice the amount of HCl in order to balance this equation. All right. Next, example number 3, sodium carbonate plus sulfuric acid. Sodium, group 1. So it's not 2+, group 1 is only plus. Carbonate, CO3 2-. So this is a classic example of, again, positive and negative charges, they do not cancel out. So in order for them to balance positive and negative, I need to have 2 sodiums for each carbonate, Na2CO3. Okay, need 2 sodiums bonded to each carbonate. Sulfuric acid is H2SO4. So sodium carbonate plus sulfuric acid forms sodium sulfate. Again, must be careful. Sodium, Na+, sulfate, you must memorize SO4 2-. So again, the plus and minus don't cancel out. To cancel out, I must have 2 times the amount of sodium bonded to sulfate. So now if you count the atoms, you count sodium for 2 on each side. You count carbonate, carbon 1, 1. Sulfur 1, 1. Oxygen 3 plus 4. So oxygen 3 plus 4, 7 on the left. How many are there? 4, 1, 2. So it goes 7 on the right. So you realize that for example 3, the equation is already balanced. All the atoms on the left and right have the same number. Okay, so you should try quick check number 4 as well. Finish all the equations there. Make sure you know how to balance them. All right, it is important that you balance them correctly, not just for your O-levels, but even for chemistry Olympiad, because balancing of equations is a key skill in chemistry. It is a first step towards you being able to do a lot more chemistry. All right, so if you are not familiar with balancing equations, most likely it's because of the ions. You're still not very familiar with what the charges are on the ions. So if you have not memorized the charges of ions, please learn. Okay, go and learn the usual ones. What are the usual ones to learn? Nitrate is one of them. All right, hydroxide, another one of them. HCO3-, hydrogen carbonate is one of them. So all these have a 1- charge. And then you have some with a 2- charge, carbonate, sulfate. And finally, lastly, you have those with a 3- charge. PO4 3-, this is phosphate, which comes from phosphoric acid. All right. So these are the ions that you should memorize. And for my Sec 4 students, if you have not memorized these, please make it a point to memorize it so that at least your equation writing will not be so difficult. Okay, so I think this is a good place to stop for today. So for today, we have finished acids, the definition of acids. We have gone through strength of acids. We have also gone through the Ka values, the acid dissociation constants, and seen some trends. We have gone through the 3 reactions of acids: acid plus metal, acid plus base, acid plus carbonate. All right, so using this, we have learned and revised how to balance chemical equations. So importantly, it's important for us to actually know all the formula of these compounds. And to write the formula correctly, you must know the formula of the ions first. Okay, so that concludes our session today. Now, next week, we will continue by talking about bases and alkalis, and we will finish off this set of notes plus the next set of notes. The next set of notes will be shorter because we will just be doing periodic table. All right. So until next week, please revise how to balance equations and the reactions of acids. All right. Thank you. Bye-bye.